Previous lecture we people discussed about the Lagrange equation of second kind. Okay, and today we are going to discuss some more results that will help us in finding some more expressions of various equations to obtain the motion. Uh, in the sequence, the first one is termed as the uniqueness of solution. Basically, what we are going to do in this article, we are going to express the given kinetic energy. No, yes, the kinetic energy into as a function of generalized coordinates, and we will express it as a sum of three terms, one which is a homogeneous function of degree 2, and one a homogeneous function of degree 1, and third one is the homogeneous function of degree 0 in velocities, in generalized velocities rather. Okay, so here it is. As we have seen that the expression for kinetic energy is T is equal to half summation k from 1 to n mk rk vector dot square as equation 1. Now all of we know that rk vector dot rk is a function of generalized coordinates t, qi and qi dots. So rk vector dot its derivative with respect to t will be partial derivative of rk with respect to qi and then derivative of qi with respect to t, that is termed as qi dot. So it will be summation I from 1 to n curly rk by curly qi dot plus curly rk by curly t. And now replace all the values of rk vector dot into equation 1. What we will obtain? P will be half summation k from 1 to n mk summation I from 1 to n curly rk by curly qi dot plus curly rk by curly t whole square. Now term these terms like a plus b square. So it will be a square plus b square plus 2ab. So the next line is half summation k from 1 to n mk, and the expression is obtained a square plus b square plus 2ab. Now multiplying half, next term is half summation k from 1 to capital N mk, and this one summation I from 1 to n curly rk by curly qi dot whole square plus half summation k from 1 to capital N mk curly rk by curly t whole square plus the third one 2 is cancelled, and then summation k from 1 to capital N mk summation I from 1 to n curly rk by curly rk by curly t and qi dot. Okay, now what we did basically, before writing equation number 4, let's see the equation number 3. It can be further written like summation I from half summation k from 1 to capital N mk, and then this is the product of two terms. First one is summation I from 1 to small n curly rk by curly qi dot, and the second term will be say summation capital K from 1 to small n curly rk by curly q capital K qk dot. Okay, in this just collect all the terms which involve small k, then it will be summation small k from 1 to capital N mk curly rk by curly qi and curly rk by curly qk. This term is represented as aik in equation number 4. Again, in the last term, just collect all the terms involving small k. It will be summation k from 1 to capital N mk curly rk by curly qi curly rk by curly t. This term is termed as ai in equation number 5. And in the third one again, the terms involving small k is summation k from 1 to capital N mk curly rk by curly t square. So this is termed as a naught. And now equation 3 is rewritten like T is equal to T2 plus T1 plus T naught. What is T2? Let me resize it so that we will be able to see all the terms. I think it's visible to you people. Okay. Uh, in 3, there are 3 terms. One is termed as T2, one is T1, and third is T0. What is T2? T2 is half, and then this AIK summation IK from 1 to capital N, AIK, and then QI dot QK dot. From equation 3, the first term is T2. Then what is T1? It's the last term. Summation I from 1 to N, and then AI as defined in equation number 5, and then QI dot. So this is your T1. And then T0, it's A naught. Simply. Because the third term in equation number 3 is A naught. Now, if you can see, T2 is a homogeneous equation of degree 2 in velocities. T1 is a homogeneous term of degree 1 in velocities, and T0 is A naught. It's simply a homogeneous term of degree 0 in velocities. So the generalized the kinetic energy is now termed into, expressed into a sum of 3 terms. Okay. Later on, it is discussed that if we are considering a Celeronomic system, means the terms are independent of T, then A naught will be 0 and AI will be 0. In that case, T will be equal to T2. Okay. There are some remarks. You can read it. If found any problem, we will discuss it tomorrow. Like various systems are discussed. After that, yes, it's theorem on variation of total energy, equation for conservative fields. Okay, now we are going to define the generalized forces, and further we are going to discuss only those systems in which the generalized force is not dependent on the generalized velocity. So, and with the help of all these terms, we will define the generalized potential force, the potential or potential energy, we can say. In the continuation, just assume that the generalized force is just a function of T, Q1, Q2, Qn, and it is not dependent on generalized velocities. If there exists some function U, which is a function of T, Q1, Q2, Qn, with the property that the negative of partial derivative of U with respect to Qi equals the ith generalized force. Okay, the partial derivative U is just some function having the property that its partial derivative with respect to ith coordinate equals the negative of the ith generalized force. Then this U is known as the potential energy, and these Qi, the generalized forces, are known as the potentials. If these terms exist and these properties holds, then we will term the generalized forces as potentials, and U, the function that exists, as the potential energy or potential of the forces. And now, as we obtained in Lagrange equation of second kind, the elementary work of forces Qi was delta A is equal to summation I from 1 to n capital Qi del Qi. Now replace del Qi with, from equation number 2, it will be summation I from 1 to n minus curly U by curly Qi del Qi. So it is variation of U. So del A is equal to minus del U. Again, if we are considering those forces which dependent on velocity component also, in that case, we will partition the expression into 2 parts. The first part which does not involves the velocity component, and the second part which involves the velocity component. The first part which does not involves the velocity component will have the properties similar to the earlier discussion, means from equation 1 to 4. And due to the equation number 2, we can write that component as minus curly u by curly qi. And the remaining terms which involves the generalized velocity will be termed as qi tilde. So qi will be equal to minus curly u by curly qi. This is that component which does not involve the generalized velocity, and plus qi tilde, or we can say qi bar. The second part involves the generalized velocity. Okay, and now the Lagrange equation will be of the type d by dt curly t by curly qi dot minus curly t by curly qi will be equal to capital Qi, and now it is minus curly u by curly qi plus capital Qi tilde. Okay, now let's discuss the total energy. What is total energy? It is the sum of kinetic energy plus potential energy. So E will be equal to T plus U. And now all of you know that T is a function of Qi and Qi, Qi and Qi dot. So dt by dt will be equal to finding the total derivative of T with respect to T using the chain rule. It will be summation I from 1 to n curly T by curly Qi into Qi dot plus curly T by curly Qi dot Qi double dot and plus curly T by curly T. And now just keep first term as it is, means summation I from 1 to n curly T by curly Qi dot as it is, no issue. But the second term, it is summation I from 1 to n curly T by curly Qi dot Qi double dot. Qi double dot can be written like d by dt of Qi dot. And now bringing this d by dt outside the summation, we will have the first term of equation number 9. It is d by dt of summation I from 1 to n curly T by curly Qi dot into Qi dot. But when we open this term, this summation, we will use the u into v method. In the first term, yes, curly T by curly Qi dot as it is, and derivative of Qi dot, it will be Qi double dot, which is the second term of the previous equation. But one more term will be there, and that term will be summation I from 1 to n d by dt of curly T by curly Qi dot into Qi dot. This term is extra, so it is included, and thus we removed this term. So in the next term of equation number 9, it is summation I from 1 to n curly T by curly Qi into Qi dot, which is the first term of the previous equation, and this is minus, sorry, it's placed plus, but it is minus d by dt of curly T by curly Qi dot into Qi dot. Yes, this is the second term which is included in the first term of equation number 9, and plus curly T by curly T. Now all of you know the Euler's formula for homogeneous functions, as T2 is homogeneous function of degree 2 in velocity. So summation I from 1 to n curly T2 by curly Qi dot into Qi dot will be equal to 2T2. Let me remind you the Euler's formula. It was if u is a function of u is a homogeneous function of degree n in variables x and y, then x into curly u by curly x plus y into curly u by curly y will be equal to n times u. Here T is a homogeneous function of degree 2 in q1 dot, q2 dot, qn dot. So summation I from 1 to n curly T2 by curly Qi dot into Qi dot, it will be equal to 2 times T2, degree into the function. Similarly, summation I from 1 to n curly T1 by curly Qi dot into Qi dot, it will be equal to degree into the function, and degree of T1 is 1. And the similar happened with T0, but degree of T0 is 0, so it is 0. Now all of you know that in the previous example we discussed that T is equal to T2 plus T1 plus T0. Replace this value of T into the first term of equation number 9. The first term will be d by dt of Yes, summation of I from 1 to n curly T2 by curly Qi dot plus summation I from 1 to n curly T1 by curly Qi dot plus summation I from 1 to n curly T naught by curly Qi dot. Replacing T with T2 plus T1 plus T naught. And now using equation 10, 11 and the third one, we will obtain the first term will be 2T2, second term will be T1 and plus third term is 0. Plus summation I from 1 to n in equation number 9. This term, the second summation, the values will be replaced from equation number 7. So it will be curly U by curly Qi minus Qi tilde. So in equation number 13, the third summation is there. It is due to the second summation in equation number 9 and equation number 7. Plus curly T by curly T as it is. Again, replace T2. Find out T2 in equation number 12. It will be T minus T1 minus T naught. T minus T1 minus T naught. Replace this value in equation number 13 of T2. What we will obtain? It will be dt by dt is equal to 2 times dt by dt plus d by dt of T1 plus 2 T naught plus dt by dt. Yes. Yes. In equation number 13, we are having summation I from 1 to n curly U by curly Qi into Qi dot. We replaced this term with du by dt. And how? Because u is a function of t and Qi. So its derivative with respect to t using the chain rule will be equal to summation I from 1 to n curly U by curly Qi into Qi dot plus curly U by curly t. So one extra term is included, that is removed. So it is written like du by dt minus curly U by curly t. And minus summation I from 1 to n Qi dot. Sorry, it's plus. Now from equation number 8, when we stated that E is equal to T plus U, so dE by dt will be equal to dt by dt plus du by dt. And now in equation number 15, we are having du by dt. On right hand side, it is 2 dt by dt. 1 dt by dt is on left hand side. So bringing that on right hand side, we will have du by dt plus dt by dt. Say this term is dE by dt. And bringing all the rest terms on the other side of summation, we will obtain summation I from 1 to n Qi tilde Qi dot, the last term, as we stated that it is minus, plus d by dt of T1 plus 2 T naught minus curly T by curly T and plus curly U by curly T. So this is the variation of the total energy as obtained in equation number 17. Now all these expressions are obtained, and then it is discussed that if we are having a celeronomic system, in that case d by dt will be 0 and so E will be constant because it will be independent of t. Okay, so there is Lagrange equation for potential forces. Basically what happens, it is just based on the Lagrange equation of second kind. Here all of you know that QIs are the generalized forces and these are the potentials. Then we will have some potential energy U is equal to TQI. In that case QI will be minus curly U by curly QI. Now define L to be a function of like T minus U. T is the kinetic energy, U is the potential energy. This very function U is known as the Lagrangian function and it will be a function of T, Qi and Qi dots. Now find out curly L by curly Qi dot, curly L by curly Qi, and then replace all these values in Lagrange equation. We will obtain the Lagrange equation for potential forces. Okay, so you should try it. Tomorrow we will start the next topic.